In this section, we will be discussing the properties of ions. The first question to ask is, what is an ion? An ion is when an extremely electronegative atom, such as chlorine, and an extremely positive atom, such as hydrogen, combine, resulting in an unequal sharing of electrons. Let us take a look at ionic solubility. As you know, polar molecules can only be dissolved by polar liquids, and nonpolar ions can only be dissolved by nonpolar. Here's why. Let's take NaCl, for example, common household salt, and H2O, which are both polar compounds. Now, NaCl, when you take its form, as I showed earlier, is very electronegative, which added to H2O, this is also very electronegative, which draws, resulting in a negative charge over here and a positive charge over here. Now these, when NaCl, the Cl will be drawn to the more positive hydrogen, and the Na will be drawn to the more positive oxygen. Now this would not work for, say, nonpolar, because if it only had a slightly negative charge, it would not be drawn fully enough to break the intermolecular forces of the hydrogen bonds. Now we will discuss boiling and melting points. First, here is a graph of heat versus changes in phase. Let's start with our basic water molecule. Here is it present as a solid, liquid, and gas. As you can see, it has a fairly normal. Now let's take in ionic. Now an ionic would have a much higher boiling or melting point, and this is a result of its intermolecular forces, which make it very hard to break the very positive charges that bind with the very negative charges. Now if you take something different, let's say something with simply London dispersal forces, it will have a very low, because it does not have nearly as strong bonds as London dispersal forces and hydrogen bonds, which such as H2O has, are not nearly as strong as the ionic bonds. Now we'll move on to ionic conductivity. Now ions are very good conductors, but why is this? The secret is in the aqueous solutions, which are mainly the most conductive, where the solids are not. You can see clearly when you conduct an electricity example that, let's take NaCl again. Na and Cl completely dissolve in water. Now, let's say you take a flow of electricity, which is a stream of electrons. These can easily be transferred completely through the solution because of the separate charges of the ions. Now, if you take a different one that does not dissociate, you'll be stuck with something that, since it doesn't dissociate at all, it will not be able to flow freely through, as there is no unequal changing in charge. Now, ionic solids are very hard and brittle, with very low thermal and electrical conductivity. This once again lies in the charges. So if you take NaCl, which forms like this in a solid, you will see that it is a poor conductor of heat because of the rigid bonds, which, because they are so difficult to break, creates an example of why it cannot be deconstructed so easily. Now if you take electrical conductivity, you will see that it's because, since Cl cannot easily be passed through directly, it has to move in a more roundabout route, which means that it will not be able to be conducted as easily. Now because of its strength of its bonds, it is also very hard, but this also makes it very brittle, because if you break a single bond, it will not be able to recreate very easily, and because of this rigid structure, which locks everything firmly in place, a single broken point will cause the entire structure to shatter. Now we will move on to the AP questions. Now the AP questions involving ions, while generally not involving much calculation, generally fall in the same pattern. You are presented usually with an ion and a different type of compound, and you are asked to determine the differences between them. Let's take, for example, this. Account for the differing boiling points in NaCl and NH3. Now, as this entire section has been about, it is once again in the bonding. Due to the extreme due to the extreme power between the bonds, as also for NH3. Now H3, as it has very easily broken intermolecular bonds, will obviously have less heat required to break them, whereas NaCl, which are much stronger intermolecular bonds, will be, of course, much harder to break. Basically, all of the problems fall in this formula, asking you to explain or also predict which will be more of a certain type, whether it could be boiling points, thermal conductivity, or even malleability compared to the brittleness of ionic solids. So this basically covers all of the AP questions present in the book, or on any future AP test.